So we're going to talk about box plots today, how to create them and how to read them. Box plots are a representation, another visual representation of the distribution of data or the spread of data. So it's another great resource to have when we're looking at statistical values. So a box plot is a representation of the distribution of a set of data points, and it's using the minimum, first quartile. Sometimes that first quartile is called the lower quartile value, median, third quartile, which is sometimes called the upper quartile, and maximum values. Also, these plots are sometimes called a box and whiskers plot. Sometimes you'll see them called that as well. Okay. Alright, so let's go ahead and walk through the steps to construct a box plot. Okay, so here's the data that we're going to be using. So the first thing I'm going to do is reorder it from least to greatest. So I'm going to start with my lowest value, 21, 21, 22, 22, 24, 25, 27, 29, 30, 30, 33, 34, 36, 37, and 43. Okay, so now it's in order least to greatest. Alright, so steps to construct a box plot. So the first thing we're going to do is identify the minimum value, the lower quartile, the median, the upper quartile, and the maximum values. So minimum value here is the lowest number, so that's going to be a 21. The median is our middle number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. So our middle number here is going to be 29. Our maximum value is the greatest number, so 43. Okay, and then here I have 7 numbers to the left of the median, so my middle value is going to be 22, and 7 numbers above that, so my median up here is going to be 34. Okay, so here are my 5 values that I needed: 21, 22, 29, 34, and 43. Alright, our next part is to draw a number line with an appropriate scale. So in this case, we're working with numbers from 21 to 43. So I'm going to draw a number line starting at 20. I'm going to go up 25, 30, 35, 40, 45, 50. Okay, and that way all my values will fit here. I'm going to plot a point above each of the 5 values. So at 21, I'm going to plot a point. So here's a point. At 22, I'm going to plot a point. Here it is. At 29, I'm going to plot a point. At 34, I'm going to plot a point. And at 43, I'm going to plot a point. So there are all of my points here. And I am going to draw a box now that goes through the lower quartile and the upper quartile values. Okay, so I'm going to draw that box. Here is my lower, goes all the way through my upper. There's my box. and I'm going to draw a vertical line through the median. So vertical line straight down through the median. Now my last step is to draw horizontal lines from the minimum to the first quartile and from the third quartile to the maximum. So horizontal line here and horizontal line here. Okay, and that's drawing a box and whiskers plot. Okay. Now we're going to answer the following questions about that box plot. So the lines extending from the box plot are sometimes called whiskers, which is why it's sometimes called a box and whiskers plot. But that just might be a little helpful piece of information for you. So the question here is about what percent of the data does the left whisker represent? So from here to here, how much of the data is shown? So if you remember, we talked about that the median is the middle number, and then the lower quartile and the upper quartile both split those medians in half. And so what happens is when we split into our quartiles, there are 4 equal parts of data. So if I take all the data and I split it into 4 pieces, then each individual piece here is 25% of the data. So the left whisker itself represents 25% of the data. Same thing for the right whisker. Even though that right line is much longer than this smaller line, there's still 25% of the data in each of those whiskers. Now, the data from the box represents the 25% from that quartile to the median and from the median to that quartile. So this is actually going to represent a total of 50% of data inside the box. Now the question here is, how would you describe the distribution of the data based on the box plot? So the fact that all of our data, 25% is very close into this area, but then there's this few numbers out here. And really, if you look at our values here, there's really 3 numbers, that are kind of thrown out way out here, and the 43 is really what's pushing us this far out here. So I would say that this data is skewed to the right. So what's important to remember about our box plot is that each section of this data is 25% of the values. It just so happens that 25% of this data fell in between 21 and 22, so it's a very close value or close set of values there. And so those are just some things to keep in mind when we talk about box plots.